Hello and welcome to this solution video. If you like this video, I would request you to give it a thumbs up, share this video with your friends and subscribe to Math United. Let's get started with question number 1. It says a cyclist and a bicycle have a total mass of 72 kg. Since both of them are moving together, so we'll take the total mass. So we'll take it as actual mass. So mass is 72 kilograms. The cyclist rides along a horizontal road against a total resistance force of 28 newtons. Find the total work done by the cyclist. That means they're asking applied work done by applied force by the cyclist to increase its speed from this to this. So initial velocity is 8 meters per second and final velocity is 16 meters per second while traveling a distance of 100 meters. So we can use the energy formula in this one. Energy formula says that the work done by the applied force is the sum of change in kinetic energy and change in potential energy. Positive or negative doesn't matter. We'll take care of that later. And the work done against the resistive force. Since it's a horizontal road, so there will not be any height difference, so potential energy change will be 0. Rest we can calculate. So the formula for delta Ke, change in potential energy, is, let me write here, half m final velocity minus initial velocity. This is the change in kinetic energy which we will be using. So 72 is the mass and the final velocity is 16. Initial velocity is 8 meters per second. There is no need to change any unit because both are in meters per second. So we are done, and now work done again resistance, and work is force times distance. Force we know is 28 newtons. Distance traveled is 100 meters, and that's it. So we'll just find this one and get the answer. So 36 multiplied by 256 minus 64 plus 2800. So it comes out to be 6912 plus 2800, which is 9712 joules. This is the work done by the cyclists. Question 2. A particle P moves in a straight line at time t seconds after leaving a point O on the line. So this is the point O. So t seconds after leaving this, that means at this particular point O, t is 0 and the displacement is also 0 because it's after leaving point O. That's what it means. P has a velocity of v meters per second somewhere here, and the equation is this: v equal to 44t minus 60 square minus 36. Find the set of values of t for which the acceleration of the particle is positive acceleration. We've been given the equation of velocity. So acceleration is nothing but the rate of change in velocity. We will differentiate the equation of velocity for this. So it will be 44 minus 2 times 6 is 12t, and it has to be positive. That means greater than 0. Differentiation of 36 is 0. I hope you understand that one. So minus 12t is kept here, and greater than negative 44. So t is less than now because we are dividing with negative 12. Whenever we divide by a negative number, the sign changes. So t is less than how much? 3.6666. So we can say t is less than 3.67 seconds. Okay. B part, find the two values at which P returns to O. P returns to O, that means the displacement. They're saying that displacement is 0, then T is what? So one of the answers we already know is T equal to 0. They're asking us to find other two values. So to find the displacement from velocity equation, we integrate. So S is V integrated with respect to time, and that will be the integration of 44t minus how much was that? 3t 6t square, 6t square minus 36 with respect to time. So S comes out to be 44t square over 2 minus 6t cube over 3 minus 36t plus C. So we have to find C, and we can use this situation when time is 0, S is 0. So when T is 0, S is 0, and we'll find value of 0, value of T. So S is 0, time is 0, so this whole thing becomes 0, this becomes 0, this is also 0, so C is 0. So we can ignore C in this equation now. So S becomes 2 and 44 cancel, 22 t square minus 3 and 6 also cancel, 2t cube minus 36t. That's the equation of displacement. They're saying it returns to O. Yeah, that was P returns to O. That means displacement becomes 0 again. So for returning to O, S is equal to 0. So it becomes that 22 t square, rather let's write t cube first. So minus 2 t cube plus 22 t square minus 36 t is equal to 0. So let's take minus 2 common in this, so that minus 2t, so that the leading coefficient becomes positive. So we'll be left with only t square in this one, minus 11 t in this one, and positive 18 in this one. Okay, this is the factor. So this gives us minus 2t equal to 0. That gives us t equal to 0, which we already know. So nothing new. We have to find the answers from this part, the other two values. So let's try that. So this is a quadratic equation. I will just split the middle term and find the answers. If you're not comfortable with this, you can use quadratic formula. So 18's factors are 9 and 2, and both negative to get minus 11. So that's what I've done. So t minus 9 minus 2, t minus 9 equal to 0. And we get t minus 9, t minus 2 equal to 0. So that gives me t equal to 9 and 2 seconds. These are the two times when this particular particle comes back to O. Question number 3. 4 coplanar forces of magnitude P, 10, 16 and 2 are shown here in the direction, and it is given that the forces are in equilibrium. That means all forces in all directions are balancing each other out. Find the values of theta and P. So to start solving this question, we should first divide or break these forces into their components. And let's start with this 10 Newton, which is making 25 degrees angle with the horizontal line. So its component in this direction will be 10 cos 25. Wherever is the angle, that becomes the cos component. Angle is with this axis, it will be cos. So the one on the opposite axis here will be the sine component, 10 sine 25. Let's talk about this 16 Newton. It is making theta with this line, this vertical axis, so it will be cos component. So we will have another force here which is 16 cos theta. And obviously there will be 16 sin theta in this direction. Now 2 Newton is making 40 degrees here, so this is the one which will be the cos component. So we'll have 2 cos 40 here, and we'll have 2 sin 40 in this direction. And there are 3 inclined forces, 1 2 3 4 5 6 components. Good. And P is in the vertical direction, so it will not be broken into any component, it will stay as P. So first we have to find theta, and for that we can balance horizontal forces. Okay, so this 10 cos 25 will be equal to 16 sin theta plus 2 cos 40. Yeah, this one force will be balancing out these two forces. So this is the equation we are getting now. So we have to isolate theta here, so let's keep 16 sin theta here and bring 2 cos 40 with this 10 cos 25 degrees minus 2 cos 40. Right, now we'll have to get rid of 16 to isolate theta later. So gone. And now if we want theta, it will be sine inverse of this whole thing, 10 cos 25 degrees minus 2 cos 40 degrees divided by 16. Let me use my calculator for this. By the time I do this, I would request you to like this video by giving it a thumbs up, share this video with your friends, and subscribe to Math United. Okay, what I'm getting here is 28.07888. So I can write 20. Okay, let's write that one first. So round it off to 28.1 degrees. That's what we should do. 1 decimal place. That's the answer. Second part is we have to find P also. For P, let's equate vertical forces. Okay, so P is the only vertical force which is going up, but there are 3 forces which are going down. So 10 sin 25 plus 16 cos 28.1, now we know theta, plus 2 sin 40. In my calculator I am putting this as 28.078, these all digits, so that I get more accurate answer. And when I put all these in my calculator, I get 19.6285548, which will be rounded off to 19.6 newtons. Question number 4. A car has a mass of 1400 kilograms. When speed of the car is v meters per second, the magnitude of the resistance or to the motion is kv square. So resistance force is kv square, where k is a constant. Okay, the car moves at a constant speed of 24 meters per second up a hill. Okay, so let's try to visualize this. This is going up a hill. This is the car. Its weight will be 1400 times 10, 14,000 newtons. It is inclined at alpha degrees, so this angle is alpha. where sine alpha is 0.12. So sine alpha is 0.12. At this speed, the magnitude of the resistance to the force is 480 newtons. Find the value of K. So resistive force is 480 newtons. K is a constant and speed is 24 meters per second. So we'll just find K now. K will be 480 divided by 24 times 24. So we get 20 out of 24, which is 5/6. That's the value of K. Find the power of the car's engine. In this case, what will be the power of the engine? Power of the engine is the force which is being applied multiplied by the speed at which it is moving at an instant. Speed is known to us, 24. So V is 24. We don't know the applied force. So let's do what? Let's see, this is the applied force in this direction. And what are the resistive forces? 480 Newton, they have already given one. And there will be one more resistive force which will be the component of this weight in this direction, which will try to bring it down. And that will be 14,000 sine alpha. Right? So these two forces will be balancing this out. Why? Because the speed is constant. And speed is constant only when applied force and resistive forces are equal. So let's find the applied force from that one is 480 plus 14,000 sine alpha, and sine alpha value is given 0.12. Okay, so that will be 480 plus 1680 comes out to be 2160 newtons. Okay, so now we know applied force is 2160 newtons. We know the speed is 24 meters per second. The power comes out to be 51,840 watts. That's the power. Okay, next part. The car now moves at a constant speed on a straight level road. So this road is straight now. Given that its engine is working at 54 kilowatts, so power is given to us 54 kilowatts, and again the speed is constant. That means the applied force will be same as resistive force, and there is no weight component this time because it is a horizontal road, so only this one. Both of them are equal, then only it will move at a constant speed. So what is Fr? Fr is kV square, right? And K we know, so resistive force becomes applied force also. They are both equal and both of them will be 5/6 V square. Why? Because they said K is constant. Yeah, though 5/6 came with a part, but they said here where K is a constant. So that means 5/6 will remain 5/6 in this question, this part as well. All right. So power is applied force times speed, right? Speed in place of applied force, we can write 5/6 V square. So 54,000 is the power, 54 kilowatts, and this is 5/6 V square, and there is one more V. That becomes VQ, and we can cross multiply this. 54,000 times 6/5. So just put cube root of the same number, 54,000 times 6/5, and we'll get velocity. Let me use my calculator. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 40.16597, that I will round off to 40.2 meters per second. Question number 5. A particle of mass 0.8 kg here is on a rough plane which is inclined at 28 degrees to the horizontal. The particle is kept at in equilibrium by a force of T Newton, which is 35 degrees angle to the line of greatest slope. Okay, the coefficient of friction is 0.2. Find the greatest and least possible values of T. There is only one trick in this. So first I will label the forces. So first there will be a weight down which will be 0.8 times 10, so 8 newtons. It will have a component in this direction which will be the sine component of the weights, 8 sine 28 degrees. There will be a component of the weight in this direction as well, which will be 8 cos 28 degrees. The T will also have a component in this direction. We should always do that because that is the surface of motion. So in this direction there should be a component of this force. So this is T, because the angle is here, so it will be cos in this direction, cos 35 degrees. So there will be a component in this direction also, which will be T sine 35 degrees. Okay, all the forces are there. There is one force left, which is the frictional force. Now for least force T, in least force T, the friction should join this particular force, so that this is reduced, it is lower, and that makes it least T, right? So in that direction, in that case the particle would like to go down, but this friction is stopping and putting it at rest and the system being in equilibrium. So this is the equation we should form for least T. So in downwards direction there is only one force, 8 sine 28, but in upward direction we have T cos 35 plus the frictional force FF. Let's evaluate FF also, which is the coefficient friction times the normal contact force. Coefficient of friction is what? 0.2. Normal contact force will be in this direction. Okay, and this R and T sine 35 will be balancing out 8 cos 28, because this system is not sinking into the surface or flying off, so they are also in equilibrium. So let me do that working here. So R plus T sine 35 are equal to 8 cos 28. So R becomes 8 cos 28 minus T sine 35 degrees, and that R we will use here. So let me make some space for this here. Okay, the R is 8 cos 28 minus T sine 35. This is what we will use here. 0.2 times 8 cos 28 minus T sine 35, and our purpose is to find T. So we'll have to open this bracket. So first evaluate 8 sine 28. 8 sine 28 comes out to be 3.7558, and there are more digits but I have rounded it off. Cos 35t will be 0.8191 t plus 0.2 times 8 will be 1.6 cos 28, right? 1.6 cos 28 will be 1.4127, and then we have minus 0.2 times t times cos sin 35. Sin 35 times 0.2 will be 0.1147, and then we have t also. So we have a t here, we have a t here, so we'll keep them here and subtract. So 0.8191 minus 0.1147 is 0.7044 t. But on the left side we'll have 3.7558 minus 1.4127. This one went to the left side. So 0.0, no, not 0, 70 equal to 2.3431. So t is 2.3431 divided by 0.7044 comes out to be 3.32637, which is about 3.33 newtons. This is the least force T, which will keep this system in equilibrium. However, for greatest, what will happen? There will be a change. So this was the body, and 8 sine 28 was the force in this direction, right? For greatest, this T has to be alone, and which will be T cos 35. And friction will join this force, so that T has to make up for friction as well as the natural force downwards, and that's why it will become the greatest force here. So our new equation for greatest force, so let me write greatest T. In that, this 8 sine 28 will be joined by the friction. So 8 sine 28 is downwards. Also, the friction is downwards. So which was 8 cos 28. That is not going to change, huh? The normal contact force will still be the same, but because of the value of T, its value will change, but the expression remains same. And now T cos 35 will be the only force upwards. There is no other force. This is the only force upwards. Friction is gone. And now we will write again. T sine 28 was 3.7558 plus 0.2 times this one was 1.4127 minus 0.2 times this was 0.1147 t equal to 0.8191 t. Now this t has to come with the other t, and these two will add up. If I add these two, I get 5.1685, and if I bring this to the other side, it will also add up. It will become positive and it will add up. That comes out to be 0.9338 t, and in this case t will be 5.1685 divided by 0.9338, which is 5.53491 more dots, and we round it off to 0.5, not 0, 5.53 newtons. This is the greatest force. That was the least force. If we have not been in casual or calculation or casual mistake, these two are the forces. Question number 6. Three particles A, B, and C of masses 5, 1, and 2 kilograms respectively lie on rest in order on a straight, smooth, horizontal track. Smooth. That means there is no resistance. Okay. So this is A, which is 5 kg. B is 1 kg. And C is 2 kg. Okay. Alright, particle is projected towards B with a speed of 6 meters per second. So it is projected in this direction. And C is projected towards B at the same instant with a speed of V meters per second. Okay. In the subsequent motion, A collides and collides with B to form D, and then D collides with C to form E and move towards Z. So this is Z, this is Y, and this is X position. Okay, so that after the second collision the speed of E is this. Okay, so we will use what? Conservation of momentum here. So the momentum before first collision is the mass times u1, then mass, which is 1, times u2 equal to, they coalesce, that means they become one mass, their final velocity. So u1 is given as 6, so 5 times 6, but there is no, it is stationary, u2 is stationary, so it will be 0, it will be equal to 6v. So 30 equal to 6v, and I think I should use v1, not v, because v is something else later on. So v1 is 30 divided by 6, which is 5 meters per second. So when this reaches to B and they collide, then they move 5 meters per second towards this C, which is also coming this way. Okay, second collision. So these two masses together now, they become one mass D, which is 6. There U1, then plus this is mass 2, its velocity is minus V. Keep in mind, the direction is opposite. Okay, so that's why I'm writing minus V, and together they make a new final velocity, let's call it V2. Okay, and 6 plus 2, all three together is 8 kilograms, so it becomes 8v2. So what do we get here? 6 u1 is given now, is, we know it, 5, so 6 times 5 minus 2v equal to 8v2, and we have to show this for v2. Okay, so what will I do? 30 minus 2v equal to 8v2, and to get rid of this 8, we'll divide both sides by 8. So v2 comes out to be this, but here all of them are even, so let's take 2 common. 15 minus v, right? 15 remaining out of 30, 2 is already out, so just v left, divided by 8. And this 2 and 8 cancel out, we get what they asked us to show. This is the collision, after second collision, the speed of E. We've shown it. Let's go to the second part. The total loss of kinetic energy of the system due to the two collisions is 63 joules. We have to show that it is V is 3. So let's say initial kinetic energy and then final kinetic energy. So initially, the what is the formula for kinetic energy? I hope you understand. What is it? Half mv square. Okay, so it will be for the first particle, it will be half. Mass was 5 kg, and the speed at which it was moving was this. Okay, this is the particle number. Let's say call it A. All right, so it comes out to be how much? 36 divided by 2 is 18 times 5 90. So 90 joules. B was stationary, so it won't have any kinetic energy, so 0 joules. C, half, and the mass was how much? 2 kilograms. 2 kilograms, and speed was v. Okay, so 2 and 2 cancel, just v square. This is the initial kinetic energy. So Ke initial is 90 plus v square. Okay, final is half, and now their total mass is 8, and their velocity we got was 15 minus v over 4. 15 minus v over 4 square. This is final. Let's simplify this one. So 4 square will be 16 times 2 is 32. 8 over 32, and let's open this bracket also. This square is applicable to both, okay? 4 as well as the numerator. So a minus b, the identity I will use here. A minus b whole square is a square plus b square minus 2ab. That's what I'm going to use here. 225 is the square of 15 plus v square minus 2 times 15, 30 v. This cancels. So it comes out to be 225 plus v square minus 30 v over 4. Now they're saying the total loss of kinetic energy is 63 joule. Loss means this is more and this is less. That's what they mean. And we'll make an equation out of this now. So it will be 90 plus v square minus 225 plus v square minus 30v over 4 is equal to 63 joules. Let's get rid of this 4. For that we'll have to multiply the whole equation by 4. So 4 times 90 is 360. 4 times v square is 4v square. Now minus will be applicable to all of them and 4 will cancel 4. So we'll just do this. So this minus is with all of them. So minus 225 minus v square plus 30v equal to 4 times 63 is 252. And this becomes a quadratic equation. 4v square minus v square is 3v square. 360 minus 25 will be 135 plus, let's write 30v first. This one. Then plus 135 minus 252 equal to 0. So 3v square plus 30v minus 117 equal to 0. Now I will use splitting the middle term method to find this. You can use quadratic formula, but first let's divide all by 3. Like we multiplied the whole equation by 4, we can divide the whole equation by the same number, so that it becomes simpler. V square plus 10v minus 39 equal to 0, and 39, two factors are 13 and 3, so yeah, v is equal to, this will be positive 13, this will be negative 13. So v equal to negative 13, it changes the sign of the root, and v equal to 3. These are the two solutions. This one is not possible, it's negative 30, it is not going in opposite direction. V equal to 3 is the right one, and that's what we had to show, v equal to 3. Next, C. It is given that the distance between x and y is 36. So let me do this way. Okay, so this is x, this is y, is 36 meters. Okay, and let's say this is z, which is 98 meters. Okay, find the time between the two collisions. So time between two collisions means between first and second collision. First, let's find how much time the first body A takes to collide with B here. Okay, this is 36 meters. Since this is a smooth surface, there is no resistance, so there will not be any deceleration. So the same speed with which it was going, what was this initial speed? 6 meters per second, right? So we will use simply the formula where time is distance over speed. So time is, it is 36 over 6 seconds. Though it is useless for this particular instance, but we will keep in mind that it took 6 seconds to collide with B. It is useful in this direction because in 6 seconds it will reach somewhere, right? And how much will it reach? Its speed came out to be 3 meters per second in previous part, v equal to 3, right? 3 meters per second it was going this way. So in 6 seconds, particle C moved how much? Speed times distance, 3 times 6, which is 18 meters. So when this was at B, it was already 80 meters away. Why? Because it has traveled 18 meters, so we'll reduce 18 out of 98. So they are at a distance of 80 meters. Okay, now this will start coming here, and what speed did we get for the particle D when they were coming this way? We got it somewhere. Yes, we got it 5 meters per second. So this started going here 5 meters per second. Let's say they collide here, somewhere here, and it travels x distance, this particular particle D. Now B, A and B together, they became D. So D is coming here in this direction with 5 meters per second for some time. I don't know how much is that time, but we know that distance is x and it will be speed times time. So x distance from here to here is 5t. In terms of t, x is this. Now this distance will be traveled by C, which will be 80 minus x, because we came to know that from here till here is 80 meters. So the remaining distance will be traveled by particle C in this direction. So 80 minus x will be equal to 3t, isn't it? 3 is the speed and t is the same time they are traveling the respective distances. Now I will substitute this x with 5t. 80 minus 5t equal to 3t. X is eliminated. So x was our assumption, it is eliminated. 80 equal to 3t plus 5t. So 80 equal to 80. So t comes out to be 80 divided by 8 10 seconds. The time between two collisions is 10 seconds. There is another part for this one. Find the time between the instant A is projected from X. We already know some time out of this. So A is projected from here to here. It takes 6 seconds. Now there is X distance. Let's find time this. And from this we have to find when E reaches Z. Okay. So after they collides, they will take some time to reach here, and that we already know now. 10 seconds is the time they came and reached here. Yeah, the collision took place here. First collision was here, second collision here. So 10 seconds. Now here total was 90, right? 98, and x came out to be how much? Did we find x? No, we did not. Let's find x. From here we can find x now. X equal to 5 times 10. T came out to be 10, so 50 meters. That means this distance is 50 meters, for which they took 10 seconds to travel. So out of 98, 48 will be left here, isn't it? Because 50 meters is till here, so 40 meters from here till here, 48 meters. Now, we know that all three particles coalesced and formed E. Now, what was their speed when they moved this way? And we found this earlier. It was 15 minus something over something. 15 minus V over 4. And V came out to be 3. Yeah? So their speed, let's call it S this time, not V, because it will confuse. 15 minus 3 over 4. 12 over 4, 3 meters per second. So this 48 meter is being covered with 3 meters per second. So time will be distance over speed 16 seconds. So it will take 16 seconds to reach here, and we got all of them. So total time, it was 6 seconds earlier, then after 10 seconds they collided, and then 16 seconds later they reached at this position C, not C, Z. So it comes out with 32 seconds. Total 32 seconds was the time that elapsed. Question 7. Two particles P and Q of masses 2.5 kg and 0.5 kg respectively are connected by a light inextensible string passes over a smooth pulley fixed at the top of the plane inclined at 30 degrees to the horizontal. Particle P is on plane Q. On plane and Q hangs below. Here. Q is 2 meters below the level of P. They've shown here. Particle P is released from rest. So U is 0 with string taut. Okay. Slides down. The plane is rough with coefficient this between the plane and the P. Okay, find the acceleration. Alright. So let's label the forces first and then we'll proceed. The first force will be the weight of this, which will be 2.5 times 10, 25 Newton. The weight of this will be 5 Newton. So since this is connected string here, it will try to pull this by 5 Newtons. But this will be the natural weight component in this direction, 25 sine 30. Okay, since there is a friction and the object is, both of them are moving this way, so there will be a friction in this direction. Okay, and the friction will be mu r. Mu is given as 0.0 2, and R will be the contact force in this direction, which is equal to the weight component in this direction, which is 25 cos 30. So it will be times 25 cos 30 degrees. We'll use this one. So let's find acceleration with this. We know that F net is applied force minus resistive force. F net is mass times acceleration. Applied force in this case is the force which is bringing it down, this 125 sin 30. And there are two resistive forces which are 5 Newton and a resistive force 0.2 times 25 cos 30 degrees. Okay, now mass in this case, because we are taking this as 5 Newton resistance in this direction, that means whole system has to be used. So the mass here will be 2.5 plus 0.5. Both masses are connected, and acceleration is acceleration. 25 and sine 30 is half, so it will be 12.5 minus 5 minus 25 times 0.2 will be 5 cos 30. So 3A is equal to, let me put this in my calculator and see what I get. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. Thank you very much. It comes out with 3.1698729. So A will be this number divided by 3. And that comes out to be 1.056624 or 1.06 meters per second square. That's the acceleration of the system and the bodies. Okay. Use the energy method to find the speed of the particle at the instant when they are at the same vertical height. Okay, so the difference between their heights right now is 2 meters, but we want them to be at same height. Let's find that one first. When they are at same height, let's take only that instance. So suppose this is the height where particle 0.5 kg increases, it moves up this much. Okay, let's take it this one. That means the particle which is 2.5 kg will move exactly same distance, right? It is not height this time. It was h here, it will be also be h. But how in actual height for potential energy, how much has it decreased? Let's see that. Let's look at only this triangle. This is 30 degrees. Let's call it x. So x over h is equal to sine 30. Sine 30 is half. So x is 0.5 h. That means whatever is h here, 0.5 h is the height dropped by the one which is 2.5 kg and sliding through the surface. Okay, that means the ratio is 1:2, isn't it? This height is double of this height, so 1:2. So 2 meters we have to divide into ratio 1:2. So I hope you understand how to do this. We just do what? Add them. So there are 3 parts of 2, right? So the first one gets 2/3 and second one gets 2 times 2/3. This is how we can divide a height into 2 parts. So this is 2/3 and this, I'm sorry, this is not 2/3, this is 4/3, and this is 2/3 of a meter. This is very important. So 2/3 meter and 4/3 meter, their ratio of 1 to 2 and their sum is 2 meters. Okay, this is what we will use in our energy method. Okay, energy method says that the work done by applied force is the sum of change in kinetic energy plus change in potential energy plus the work done against resistance. Since this system has been just let go from rest and it is moving on its own, there is no continuous applied force. There is only one continuous applied force, which is due to gravity, right? But that will be taken care of by the potential energy. Okay, so there is no external force which is bringing it down. Kinetic energy, the difference in kinetic energy, because both of them are moving together and their velocity speeds are also same, so it will use their mass together, which is 3 kilogram, 2.5 plus 0.5, and v square is they're asking what is their speed when they are at same height, and initially they were at 0, right? So change in kinetic energy is taken care of, but the potential energy is a little different, because one particle is losing potential energy, it is going down, and the other particle is gaining potential energy. So we have to increase one and decrease one. All right, so let's talk about the one which is hanging 0.5 kg. It goes up by how much? We just found out 4/3 meters, right? So m, g and h, this is the gain by the first body, but the second body, which is 2.5 kg, will be let's write here plus. Okay, its mass is 2.5, then g is 10, but it is decreasing, it is going down by -2/3 meters. So this is the potential energy difference. One is gaining, one is losing. And then we have work done against resistance. The resistance is the frictional force, which was here 0.225 cos 30. So we know work done is force times distance, right? So how much distance have that particular body moved because of friction? How much work? This is the distance it has moved, this one. So which was exactly 4/3, equal to this one. Yeah, the amount it went up, the same amount it went along the surface. So 4/3 will be the distance we'll take, and force is 0.2 times 25 cos 30, and now distance is 4/3. This is our energy method. Okay, so let's cancel this and this. 1.5, so 0 equal to 1.5 v square. Okay, plus, so this can be 5 times 4, 20/3. Now this will be 25, and 25 minus 50/3. Okay, I'm using mental math. You can use your calculator, please. So this is 5 cos 30, 5 times 4, 20/3. 20/3 cos 30. 30. Okay, so now let's move this to the other side. So it will become minus 1.5 v square equal to this, and this will be minus 30/3, which is minus 10, plus 20/3 cos 30. Okay, this, so v square equal to minus 10 plus 20/3 cos 30 degrees divided by 1.5, negative 1.5. So v square comes out to be 2.8176464. There are more digits after this. and we will square root this to find the final speed of the both the bodies when they are at same height. It comes out to be 1.6785889. We will round it off to three significant figures, 1.68 meters per second.